Solving word problems. Example 1. A battery, a known resistor with a value of 3 ohms, and an unknown resistor are connected in a series. The amp meter reads to be 1 amp. Another resistor with a known value of 10 ohms then replaces the resistor with the value of 3 ohms. The amp meter reads to be now 0.5 amps now. Find the voltage of the battery and the value of the unknown resistor. So here we have a word problem we need to solve. So what's important to remember is we need to remember this equation. V, or it can be written as E, is equal to I times R. So I stands for current, R is for resistance. Now this resistance is in a series, so we know we can just add those up. So we know that V should be equal to I, and we have two resistors. We have R1 plus R2. So for equation 1, let's look at this. We have a known resistor of 3 ohms. And we don't know what the voltage is. So we have voltage equals I, which is then equal to 1. So we have 1, and then we have 3 plus R2. So that's our first equation. Our next equation is we have the same voltage, but this time we have a resistor of 10 ohms, and the amp needs to be 0.5 amps. So we would put 0.5, and then we put 10 plus R2, because we're solving for the second resistor or in voltage. So now we have our two equations. And so what I would do, I would solve by substitution, because what this voltage is it's already set up to be a substitution problem. So we can just put this voltage into equation 1. So anytime you see V in the second equation, you would insert this whole 1. So I would substitute 1 into 2. So then we get 1 times 3 plus R2 equals 0.5 times 10 plus R2. Let's go ahead and multiply. We have 1 times 3, so that's 3. 1 times R2, so that's just R2. Now we have on the right hand side, we have 0.5, so it's 1/2 times 10, so that's 5. And 0.5 times R2 is 0.5 R2. Now we need to go ahead and solve for R2. So we would go ahead and subtract 0.5 to both sides. This gets rid of it here. Then we have 3 plus 0.5 R2, because if we were to go 1 minus 0.5, we get 0.5, which is equal to 5. Now we need to go ahead and subtract 3 from both sides. We get 0.5 R2 equals 5 minus 3, so that's 2. We go ahead and divide by 0.5 to both sides. So we get 2 divided by 0.5, and we get 4. So our resistor is 4 ohms. Now we can go ahead and solve for voltage. So let's go ahead and now substitute R2 equals 4 into equation 2. So we have voltage equals 0.5 times 10 plus 4. So we have voltage equals 0.5. Well, first deal with 10 plus 4, so that's 14. Now we have voltage equals 0.5 times 14. So 1/2 times 14 is 7. We can always get our calculators out. 0.5 times 14, we get 7. And this is in voltage. So we have our two unknowns solved for. Now let's do another example. Example 2. A circuit has two resistive branches. The current in one branch is 8 milliamps greater than the other branch. The current flowing from source is 24 milliamps. Calculate the current flowing through each branch. So we need to set up our two equations because we have two unknowns, because we're solving for current in each branch. So we know that the current in one branch is 8 milliamps greater than the other. So how we can set that up is we'll say B1, so branch 1, is equal to branch 2, but it's 8 greater. So we'd have to add 8 to branch 2 in order to be equal to branch 1. So see, that is also to show equals 8 plus the other one. Now we have the current flowing from the source is 24 milliamps. So that means B1 plus B2 equals 24. So we have our two equations with our two unknowns, so we can solve. And I would solve by substitution because equation 1 is already ready to go for substitution. So I would substitute B1 equals B2 plus 8 into 2. So how we would do that, we would go, so we would substitute this, so B2 plus 8 plus B2 equals 24. Now we need to simplify. So we have B2 plus B2, so that's 2B2 plus 8 equals 24. We can go ahead and subtract 8 from both sides. So we get 2B2 all by itself. This becomes 0. 24 minus 8 is 16. We can go ahead and divide by 2 on both sides. And we get 16 divided by 2 is equal to 8. So B2 is equal to 8 milliamps. Now we need to solve for B1. So in order to do that, we can go either equation 1 or 2. So B1 equals, so this is equation 1, use B2 equals 8. So 8 plus 8, so now B1 is equal to 8 plus 8, which is 16 milliamps. Now if you wanted to do, say, equation 2, you can see you'd get the same answer, because you'd get B1 plus 8 equals 24. We go ahead and subtract 8 on both sides, and we get B1 equals 16. So either way, we would have got to our right answer if we substitute B2 equals 8 into equation 1 or 2.